Welcome to Control System classes. The topic for today's discussion is the procedure for the root locus from electrical engineering talk. What is root locus? It is a graphical method to determine the stability of the system. What will be the given function? The given function is open loop transfer function g of s. G of s will involve with the parameter system gain k multiplied by the numerator polynomial divided by the denominator polynomial. The system gain k, when it is varied from 0 to infinity, then it is called direct root locus. When k is varied from minus infinity to 0, then it is called indirect root locus. Most of the time, we'll discuss about the direct root locus. So easily from the root locus, graphical method, we can able to determine the stability and we can adjust the value of k so that the system will become stable. So let us discuss about the procedure of root locus. The root locus is drawn on the S-plane. The S-plane represented as the S-plane real axis. X-axis is represented by sigma. It is a real axis. And the imaginary axis is j omega, which is nothing but a y-axis. Usually, the root locus is a symmetrical plot. So, the scale on the above real axis and below real axis would be the same always. It is a symmetrical plot. The first step is to find the location of poles and zeros. So from the given transfer function g of s, equate the numerator polynomial to 0. That is nothing but as zeros. The zeros will be marked by a small circle. Equate the denominator polynomial to 0, which will give the poles. It will be usually marked with a cross. So this is a representation of poles and zero representation in a root locus method. Even it is applicable for a complex poles and complex zeros. The second step is to find the number of root locus branches. The number of root locus branches is represented by a symbol n. Then capital P represents number of poles, capital Z represents number of zeros. Usually a proper polynomial is a 1 which has the denominator power to be greater than the numerator power. So it means P will be greater than Z. This will be the usual scenario. For some case, you may have P is equal to Z. So when P is greater than Z number of branches will end at 0. Z number of branches will end at 0 and then P minus Z branches will approach infinity in search of 0. So we have discussed about a branch. What is a branch? A branch is a thing which will start at a pole. A branch is a one which will start at a pole and it will end at 0. So always the direction is from a pole to 0. So whenever there is an absence of 0, then only the branch will approach to a infinity to find a 0. So for example, my P is equal to 5. Let us assume my P is 5. My Z is equal to 2. So it means 5 minus 2 is 3. It means 3 branches will approach infinity here. Remaining 2 branches will end at open loop zeros. That is a concept here. When P is equal to Z, none of the branches will approach infinity. All the branches will start at the open loop pole and it will end at open loop zeros. So always the given function will be a proper polynomial. So this will be the case. The worst case will be the scenario when Z is greater than P. When Z is greater than P, the number of branches will be equal to the number of zeros. But that will not be the condition for the given problem always. So concentrate on the first two cases. Then the third step is you need to determine where there is a possibility of root locus existence when k is varied from 0 to infinity. In order to do this procedure, we need to follow a trick here. So here the poles and zeros are marked as per the given problem. Now you choose a test point here between every poles and zeros. To the left of every poles and zeros, take a test point. Now to the right of test point, you count the number of real poles and zeros. You should not consider a complex poles and complex zero at this step, right? So only calculate, only determine, find the or only check the number of real poles and real zeros. So to right of my point A, I have one pole. It is an odd number. So between these 2 points, there is a possibility of root locus existence. Now similarly, let us take a test point to the left of next pole, next real pole. Then to the right of my pole, I have real number of total number of real poles and real zero is 2. So the root locus will not exist here. Similarly, assume a test point here to the left of point -5 that is named as point C. To the right of point C, the total number of real poles and real zero is 3, which is an odd number. So that's a possibility of existence of root locus. The step number 4 is angle of asymptotes and centroid. So this is a reflection of step number 2. So how many branches is going to approach infinity? That much asymptotes you need to calculate. What is an asymptote? Asymptotes are simply a guidelines how the branches will approach infinity. So how many asymptotes you will calculate? How many branches is going to approach infinity? P minus Z branches. So P minus Z branches you need to calculate for the asymptotes. As per your requirement, as per your calculation in step number 2, you calculate that much asymptote. What is the formula I can use for asymptote? The asymptote formula is angle of asymptote is plus or minus 180 degree into 2q plus 1 divided by p minus z. So this is the formula of angle of asymptote. What is q here? Q is nothing but the value vary between 0 to p minus z minus 1. Right? What is P? Number of poles. What is Z? Number of zeros. So how many asymptotes you require, you need to calculate. Always the asymptotes will occur in pairs, plus or minus. Suppose you require 2 asymptotes, so substitute Q as 0, it is sufficient. Suppose you require 4 asymptotes, substitute Q as 0 and 1. Suppose you require 3 asymptotes, substitute Q as 0, take 2 values. Substitute Q as 1, take the first value alone. First value means positive value alone. So can you understand? Number of asymptotes, what you require, that much asymptotes alone we need to calculate. What is centroid then? Where the asymptotes will meet the real axis, that is called centroid. The centroid is sum of poles minus sum of zeros divided by P minus Z. Sum of poles, sum of zeros. It is nothing but the poles when it is that is when the denominator polynomial equated to 0, that pole value, sum of zeros means the numerator polynomial equated to 0, that roots you need to substitute there. So centroid and asymptote you need to calculate only if the branches are going to approach infinity. When it is not going to approach infinity, you can skip the step. Then breakaway breaking. Whenever you have a possibility of the branches to approach infinity, to break away from the real axis, you can calculate breakaway and breaking. For example, let us consider the case. I have double poles here. Now this poles want to meet zeros. So it means there is only chance it don't have zeros on the real axis. It means it has to approach 0 at the infinity alone. So during the time, this pole will start at the pole at the point of breakaway. It will break and it will approach infinity in search of zeros. Similarly, this pole will also start here. It will meet the breakaway point, then it will approach infinity in search of zeros. I already told root locus is a symmetrical plot. So above the real axis, below the real axis, the shapes will be the same. So when the branches are breakaway from the real axis, then it is called breakaway, right? So between two poles, if a point is coming out, it is breakaway. You can see from the arrow direction. The branches breaks away from the real axis and it will approach infinity in search of zeros. You will now look at the case here. Let us consider a case here. I have 2 zeros. So always where a branch will start, it will start at a pole. So let us assume I have a complex pole here. I have a complex poles or any other pole. Anywhere it may have a pole. So anywhere, even it may be real poles, right? So from this pole, let a branch, this pole need to meet the zeros. So it has to enter the real axis. So it will enter at the point and it will end at the 0. And it will end at the 0. Look at the arrow direction. Similarly, this pole, it will start, it will enter the breaking point and it will reach the zeros. Now, this point is called breaking point. The first point is called breakaway point, right? So when the root locus breaks away from the real axis is called breakaway. When the root locus enters the real axis, then it is called breaking. When you have one pole and another 0, there may be a chance of having breakaway or breaking. Depending upon your problem requirement, you can able to conclude it as breakaway or break-in. Now, calculate this breakaway or break-in. So, what is the given function? The given function is g of s. So, from the g of s, you need to write that characteristic equation. What is characteristics equation? 1 plus g of s h of s. You need to write the characteristic equation 1 plus g of s h of s. H of s is unity feedback negative, that is feedback value. If it is unity feedback, h of s value is 1. So 1 plus g of s h of s equated to 0. So from this equation, write k, then you differentiate it with respect to that is the differentiate k with respect to s, then equate it to 0, find the roots, you will get the roots in s, then substitute the roots of s in k equation. When k equation is positive, there may be a chance of breakaway or break-in. Is it right? As we are discussing direct root locus, k value to become positive, right? And also keep in mind it should satisfy step number 3. That should be that is the s value what you are calculating here. There should be the possibility of existence of root locus from step number 3. So when you are solving this problem, when you are solving this step, you need to also cross check the step number 3. So the roots what you are calculating should be substituted, there should be the existence of root locus from step number 3. Those value of s alone you need to consider and substitute in k, and if k is positive, there may be a possibility of breakaway or break-in, or else this process will not occur. So depending upon the problem scenario, you need to able to check whether there is a possibility of breakaway or break-in. Let's move to the next step. The next step is angle of departure, angle of arrival. Angle of departure, from the name itself you can say angle of departure. Always the branch will depart from the pole and it will approach as 0. Angle of arrival means the arrival point is always 0. Is it right? So whenever you have a complex poles, calculate angle of departure. Whenever you have a complex zeros, you need to calculate angle of arrival. When you don't have complex poles and complex zeros from the step number 1, you can skip step number 6. Right? So how to calculate angle of departure, angle of arrival? So here my complex poles are named as A and A star. So we have complex poles and complex zeros. Now from all the real poles and the real zeros, you connect the complex poles, any one of complex poles. I have joined to A. Now using your protractor, you measure the angles of all poles, that is with respect to negative real axis. Measure as per the arrow directions given. Keep your protractor here and measure the angles. Then the angle of departure is 180 degree minus sum of angles of vectors to the complex from all poles. So what are the angles you measured with respect to complex pole A? That is, poles are at theta 1, then theta 3, then theta 5. So 180 degree minus theta 1 plus theta 3 plus theta 5 plus theta 2 plus theta 4. Hope you understood. So when you got the answer as A as some x degrees, then the answer will be minus x degrees at A star. Right? The same procedure is for angle of arrival. You need to connect all the poles and zeros to the complex 0. A and A star is in complex 0. The procedure is same. The formula is 180 degree minus sum of angles of vectors to the complex 0 A from all other zeros plus sum of angles of vectors to the complex pole, complex 0 A from the poles. So the usual procedure, angle of departure, angle of arrival, we need to calculate when you have complex poles and complex zeros, or else you can skip this step. The step number 7 is intersection with the imaginary axis. As we know that the branches may approach infinity. For example, let us consider the branch can go to infinity by following this shape from the real axis, or else the branch may go from the point, it may go to the infinity by following this shape. So whether there is a possibility of intersection with an imaginary axis, we need to find and we need to verify in order to determine the stability of the system. This is also an equally important. Is it right? So to determine this, you can go with Rouse-Array method or trial and error method. So when the final answer from the root locus is the stability. So when the branches are in the left of S plane, when this side the system is stable. When the branches are in the RHS, the system is unstable. When the branches meet the imaginary axis, that is at this point the system is said to be marginally stable. So when you are solving the problem, we will discuss. Thank you.